blow it up if it's actually
Okay, Jonathan.
Oh, that's a good idea.
I'm live in HMI. Let's go through it. So we have our external ear, or pinna, or auricle. Then we have our external auditory canal / external acoustic meatus / some word that means tube in here. That's going to hit my tympanic membrane or eardrum, which is connected to my 3 ossicles. So I have my malleus, or hammers, the first, my incus, or anvils, the second. My stapes is on this model here. And together, those are in the tympanic cavity, or middle ear cavity. Then my cavity drains down my eustachian, or pharyngotympanic, or internal auditory tube. Then we have, this here is the inner ear, or bony labyrinth, which has the cochlea here, the semicircular canals here, and the vestibule in between. So if I look, if I were to take off my stapes, there'd be an oval window where this vibration enters the cochlea, and then there's a round window where the vibration is absorbed, coming out basically of the cochlea. And all these structures would go through my vestibulocochlear nerve. Vestibular branch would go here, cochlear branch would go there. So then if I'm looking, my semicircular canals, there are 3, so if I do them, this would be the anterior, front, posterior, or back, lateral, or sideways. And then each one has an ampulla, which is the thick area where they're sort of connected, and that would contain the crista ampullaris and the structures to detect dynamic motion. My vestibule has 2 bumps, these and these, which are the utricle and saccule. Those contain the otoliths to measure static equilibrium. And then, that we're going to zoom in on over here. So in this model, oval window would be the A, round window would be the C, so in and out, basically. I can have my cochlea, semicircular canals, utricle, and saccule. So we're going to focus on this part first. So again, I have my anterior, posterior, lateral semicircular canals. They have an ampulla, which is the bulb at the bottom, inside of which would be the crista ampullaris. Each of these is full of endolymph, as well as the utricle and saccule, and that's made and stored by the endolymphatic sac, which is over here. These 2 contain the otoliths, which determine static equilibrium. Over here, if I open up my cochlea, I can see the tubing inside that represent where the vibrations and the lymph would travel. So that's this, up close and personal. So let's zoom over to here. So these 3 things here represent these 3 things here. So this one's the scala vestibuli, or the vestibular duct, full of perilymph. That travels through the cochlea and also comes down here, the scala tympani, or tympanic duct, which is also perilymph. This little triangle is the cochlear duct, or scala media, which contains endolymph. And this is the vestibular membrane, because it's pointing to the vestibular duct. This is the tectorial membrane, because it bends. And the basilar or basilar membrane is along the bottom here, where the stereocilia and the cells are anchored. So this vibrates, pushes this vibrates, pushes this fluid, which pushes this, which pushes them, which sends an impulse down these nerves to spiral ganglion, eventually out to the cochlear nerve, the vestibulocochlear branch. And the oval window is pushing onto this, the round window is absorbing from that. I think that's all.
Tongue?
Tongue.
Taste?
Tongue and taste. Let's do that. So on my tongue model, which I really don't particularly like much, so we have our bumps, which is the papilla, and the only bumps which are very clear on this model are these ones here, which are circumvallates, which are the double circle, and so the taste buds would be on the sides of those valleys on that. That's really all I can ask you on that one.